Okay. So, as I told you earlier, Oracle is the number one according to the ranking, as you can see. For some time now, I think it's one of the industry standards where compared to the other models. So, which I believe that this foundation will be helpful for you. Right. Before we move on, um, let's start with the basics of why we need to learn databases in general. Because we know that today is a data-driven society, and everywhere we talk about data analytics and artificial intelligence, which means all these tools use a lot of data. Like I hope many of you are now using ChatGPT, which is very large language model built on the available data on the web. So which means as a organization, we need to, store the data in different formats. Of course, in this session, we are going to talk about relational databases, which is structured method or structured databases, which we use based on relational data tables. So we need to record in some form. So in some cases, when we have data, we need databases, but in some cases, you don't need really a database, depend on your application. So data come in various forms, but we need to have access in a structured way so that we can easily manipulate the data. So that's what we are trying to discuss in this session. Right. Now, when we talk about the data, we know that it's a known fact, so recorded in some way. And hope since you all are working in the industry, you might also have data in different forms in text files, Excel files, and so on. But when it comes to term database, we talk about the data in a related manner. That means we talk about related data. Now, for example, when we take, for example, university environment, we can record the details about the students, the courses, the lecturers in different tables so that we can have the data in related tables. Now, when we collect data, one thing we need to remember, we collect data for some purpose, right? So, for example, in university education, we want to keep track of, student environment, their demographic information, and also like maybe their, educational information. So, usually we start with, some purpose to collect the data, and which actually represents the real world, right? And there will be some logical organization. So that's the basic understanding when we need to talk about the databases. Now, once you know the databases, we have to talk about the database management systems. I told you like we are going to use Oracle database management system. So what Oracle provides us for, it will be a software package. In our case, we are going to use Oracle Express Edition, which can be installed in your machine as a standalone application. So installation and also like how to use them, I will cover in a separate session, in practical session. The first 2 days, we'll talk about basically the theoretical aspect of this. And from the third session onwards, we are going to start looking at how really implement those. So now, having said that it's a software package, it provides us several operations we can perform with the database management systems. The first one is we need to define a database. Usually data, I told you, we created databases for intended purpose. So if it is a university, we can create a database for the university, right? So what we have is you will have a set of files, records, fields, as well as we will have physical and logical links, which I will discuss in coming sessions. Then you can construct that. the database so that we can store the data. Next, we should be able to manipulate, which means we can insert data, we can delete, we can modify, and finally, end of the day, we need to generate, summarize, right? And we can also make use of data for analytics, for example. So which means we can use to manipulate the data. Right. Now, when we take the whole database system, when you say a database system, the term we can use to talk about two things together. That means our database management system software plus the data itself. Now, sometimes it's not just the database management system. There will be some applications as well. Now, for example, Oracle database where we can use to store the data, and then we can store the data. So those are to the other database system. Then we can have some front-end environment which we can use, for example, web-based application or the mobile application where you can talk to our backend where the database system is. So that's how usually we communicate with our database. Right, now we got some idea about some functionality. So when we talk about defining the database, I told you that the first task that we are going to do. Now, when we talk about the databases, then we have to think about what are the types of data we are going to store. Now, I told you about the university data environment. Let's say you are going to store about the student information. So we can create a database to store student information. So when we say name, for example, so we can define its character, or you can say string. So likewise, we can talk about different data types. We sometimes call domain. So the data could come from different domain. For example, if you say gender, then we usually have like two different values, let's say male and female, coming from predefined set of categories. So those are the types which we have to define when you are database. Then you have to define the structure. For example, in a student information, we can have name, gender, other information. And for example, we usually have a unique attribute to individually identify each of the students, like let's say index number, which are special, attributes we use to uniquely identify. And then we can have some different constraints depend on our requirement. For example, let's say a person's age could be in coming from different intervals. If you say student grades could come from different categories. So likewise, we can define constraints when you define a database. Now, once you define the database, we can construct or load the database. Now, when you say construct, sometimes we can start the database from the very beginning. Let's say we are developing a new database application. In that case, we can construct the database, we can store the data. Second one, maybe we are developing a database to already existing application. Maybe it could be it's a manual system where we want to computerize it. So we have to load the data set. Right. Then manipulating, we already discussed. We can get different information. We can combine the data available in several tables. We can insert, delete, modify, and so on. Right. Now, this is the last one, is very important. Now, if you're thinking only the first three things, you might think that, okay, we don't need a database. Why we can use a Excel sheet, for example. Now, remember, we are using database for special purpose. Think about using your data from multiple users. So that means sometimes we create a database to connect with, millions of users. When multiple users are accessing your data, we have to provide information concurrently at the same time, and we can share the data, right? Now, for example, think about a situation where you are going to purchase some item from the web. Let's say you have only one item available, and let's say 10 users trying to, purchase the single item. So how do you handle such situation? So in a case like this, we need to make use of database management system. So it not just we store the data. Your requirement is just to store the data, and if you are not going to change much, maybe you don't need a database. Think about the application where multiple users are trying to access your data, and multiple users are trying to, change, add data. So then you need a database management system, right? So why I actually stress this one? Because depending on how users are using the data, we have to make sure that data is valid and consistent, because there are things might be fail in the middle, right? We might, okay, for example, we might, insert the data, and halfway through, maybe power goes off, and something might not completely done your insertion of the data. So how do you handle such a situation? So the database management systems can handle all these cases. So that's why we need to use a database management system. Giving you a simplified environment look like this. So when we look at in a database in a simple graphics like this, you can see we are going to create or store our actual data. This is what we see here in this symbol. And then I told you in the beginning, when we create the database, we have to define what are the, valid data we are going to use. That means the different data types we are going to use, different constraints that we are going to have. So the data about data will be separated. You can see it's called metadata. Then we have the database management system software, which will, interact with these. So to interact with these, there are two components. One thing is software to process queries and the programming coming from the outside users. And then we have another module where actually it accesses the internal storage, actually stored data. And how users are using the data, right? For example, there could be two types of users we can think of. So for example, general users. I think when we interact with the database application like web applications, you might be familiar with, filling forms. When you fill a form, the data will be stored in a database. So that filling forms you through some application form, right? That's one way to interact with the database if you have an application. The other way is what we are going to learn in this module. We as a programmers, as technical persons who are going to interact directly with the database using what we call queries. So we are going to learn SQL, structured query language, where we can use to write SQL statement to directly talk to the database and get the data, right? So this will actually gives you our whole database system. So when you put everything together, so we can talk about database system. So I hope you got the basic understanding about what data is, what a database is, what a database management system is, and how a database system look like. Right. Now, let me give you some tabular information where you will see how you are going to create database. Right. So in this set of tables, actually sample data sets that we are going to discuss when we create the database for a university. So you can see there are several tables in the database. So one is student, another one is course, another one is section, another one is grade report and prerequisites. So this will represent some aspect of university where we will talk about student, taking courses and their performance based on the grades. And we have logically organized. That's why we have several tables. If you ask me like how we are going to do this, we will have the next session. We talk about the data modeling part, where when you're given a data requirement, we will learn how to create tables. For the time being, let's say this is a database, and we have several tables we have created. The next thing that you need notice is each of these table, you have a set of attributes. So these columns represent different attributes which will describe the student. Now, currently, we describe a student using name, student number, class, and major, right? So this information we have to decide when we are designing a table. Right now, we have two records. Similar to that, course can be described in this particular using course name, course number, credit hours, and the department. Similar to that, the section, that means in different courses, different people teach different sections. So section information is given here. So you have a section identifier, course number, semester, year, and instructor. Right. So these are what I called attributes, or you can say data elements. Each of these elements, you have some data type. Now, for example, when you say student, we have name, it's a string. Student number, it's an integer. So that is also one thing we have to decide in the beginning, in the design stage. Similar to that, if you look at grade report, right? So grade, you have some character, right? So grade report, if you take grade, for example, data type, we can define as a single character. So similar to that, in the design stage, we have to, identify this information. Right. Now that we have looked at and got some basic understanding about the databases, we need to discuss something called data models, right? What it means is this data capturing, the way we capture, there are different ways that we can capture the data, right? So data model means it's a set of concepts which we can use to describe the structure of the database. And of course, some constraints that we need to obey. Now, when I say constraint, the simple example would be, I told you, like, for example, if you take age of a person, you have to have a set of range that the data comes from. Similar to that, let's say marks of a subject, again, the mark should come from 0 to 100. So likewise, there should be some constraint which we make sure that the data is consistent. Then we have data model operations. So depending on the data model that we have select, there are some operations that we can perform. So that means in a database, we know that we can retrieve the data. That means you store and then you can retrieve. And then you store the data, you can make changes. We can say updates. So everything should be based on the data model that we have selected. So in any data model, we can talk about some basic operations, and then we can talk about some user-defined operations. Right. Now, having understood the purpose of the data model, let's try to understand some categories. Right. Now, when we create, databases, we can create data model in different levels. When we start in the beginning of creating a database, we should look at very high level data model, which we call conceptual data model. That means how we might see the data. That is in generally. So usually we develop conceptual data model to understand the data requirement. Second model is physical, which means we need to know how the data is actually stored in a computer, right? Especially how the storage is handled. So this is called physical data model, which we call low-level models. Then last one we call implementation data model. That means it's in between these two, basically in between the very high level data model to physical data model, right? How do you, balance how user view the data and how actually data is stored? So why we need to know is because it matters when it comes to retrieval. Now think about an application where time it takes to execute a query. It's very important. For example, that financial market, for example, it's very crucial that when you make a decision, the time it takes should be very minimal so that it won't affect the user's decision. So the time matters. For example, think about how the data coming from when you perform a Google search query. So within a fraction of a second, you will get the millions of records, right? So our database should, handle these kind of a situation. Right. Now, when it comes to defining these database schemas, we can define database schemas in 3 levels. First one, we can talk about internal schema, which means it can describe how actually we store the data. For example, in a storage level, how exactly data is stored, we can define using internal schema. This is very, very important because I told you the time it takes to access the data, it matters. For example, I told you about the financial market data. If the data is stored in your hard disk, time it takes to access the data in the hard disk to your main memory, it matters. So we have to make sure that we can quickly find the required information. So we have to define things like indexes, which we are going to discuss. That affects the query performance, how long it will take to access the data. Then conceptual schema, right? So in conceptual schema, we will describe the structure and also the constraints, right? So the conceptual schema which will describe those information, right? Now, for example, I told you like data will be in separate related tables. So for example, students will take different courses. So usually how we handle, we have a table for student, we have a table for courses, and we have another table which connects these two, right? So that there will be some logical connection between these two, right? So which we can describe using a conceptual schema. Then the next one is external schema. Now, although we store the data in different tables, when we actually view the data, we see in a single view, right? If you are a just user, usually you won't see the different tables, although we discuss about, student data will be stored in separately, courses will be separately, and so on. So usually it will be a single view where we can get information such as like, okay, student and what are the courses that they are taking in a single view. So we call external schemas. So we can create a view to combine these different tables so that you will see a just single view where you can see all the data. Right. Now that we have understood about different levels, so this will graphically show you what we have discussed. So there will be some external views. Depending on different users, you will get different views. Okay, so for example, in any applications, there'll be a different users. Some users, they enter the data. Some users, they only retrieve the data. Some get, summary view, like a dashboard. So depending on different users, we have to provide different external views. But the data coming from one conceptual level where we have the data, but actual storage might be different. So for example, data might be stored in multiple different databases. For example, in Google, when you perform a Google search query, data will come from multiple different databases. So it's not a centralized or data, data will not come from a one single source. It will come in from multiple sources. So that will handle through the, internal level, we call internal schema. Right. Okay, so this is what we call the three schema architecture, and most of the relational databases, we will see these three schema architecture, right? So the interesting point here is when you make the change in one level, it won't affect the other level. So that means we can make changes in the internal level, storage level, changing how we, access individual data elements. We can change this without affecting the conceptual level, the upper level. Similar to that, without affecting the conceptual, we make changes to the conceptual level, which might not affect the external level. So this is what we call data independence. So one advantage you will get by using these three different levels, that we can talk about different levels of data independence. Now, logical data independence, we say that you can change the conceptual level without changing the external schema. So what it means, we can change here, but whatever the programs that you actually use the data, it won't affect. So this is called logical data independence. The next one we call physical data independence, which means you can change here without affecting to the conceptual schema. So this is called physical data independence. So it's very important that once you develop the database system, you can make changes into one level without affecting the upper level. So that is one of the advantages you might get when you have database management system which adhere to three schema architecture like this. Right. So when you make changes in lower level, only change that you need to do is only the mapping, right? So because it fully supports the data independence. So which means the higher level schema will not change. And you don't need to make changes every time when you change into the lower level. So that is one of the advantages you will get with the database systems, which defines these three levels and with the data independence that we have discussed. Right. Now that we got some understanding about the database systems, let's look at different components available in the database management system. So you can see that it's very complex software system, although we don't see, when you say a software, you don't see it as a complex software system because it's just a software. But it's like a building, like a multi-story, building. It's very complex, right? So therefore, we can talk about multiple different components. Right. So this graph shows you some aspect of database system. What it shows you is different types of users which uses the database. Now, for example, what we discuss in this module is like a database administrators, like we learn theory how to access the database, right? Directly using SQL statements. So this is one side of it. Then there are some casual users like maybe top management where they can, access the data, whatever the required data separately. Then there are developers, which we call application programmers, who develop the application for the other users. So they can use application programs to interact with the database. And then there will be some general users, right? When you say general user, they will use what we call pre-compiled, transactions or pre-compiled, statements. Now think about you access your financial information using ATM. You use the card to withdraw money. So you see that when you go to a bank, you see a typical selection, and that's what you will get, right? There's no user-defined, functions. They are predefined. For example, when you want to withdraw money, okay, there are designated amounts that you can withdraw directly, easily. But if you want to withdraw some custom amount, you have to take different path. So likewise, there will be some predefined, transactions. So the users we call parametric users. So which means you now understand the database management system should support all these different types of users. So the database system should support some general users with compiled transactions. Database system should support for those who are developing applications. Database system should support for casual users, as well as database should also support for the database administrator staff, which define users. Now, for example, I told you there could be, multiple different users are there. So some users are allowed to enter the data, that's all. So they can only enter the data to the database. Some users are allowed to enter and view the data. Some users are allowed to, enter and then view and also edit the data. Some users are presented with the summary data. So all these could be defined by database administrators. So they can give different privileges. So some can read only, some can also provide both read and write, privileges. So likewise, you can see. So in this one, you can see the overall architecture of, database. And as you can see, we have a place where we have the actual database, and also we have a data dictionary. That means we will also maintain data about data. Right. Okay. Now that we have got an understanding about, different database components, now you can see there are various database management systems. We have already seen that there are different databases are available. We have seen the rankings. So likewise, if you look at nowadays, there are various database management systems are there. Now, these different databases we can classify based on their data model, right? So what the data model that we are discussing right now is called the relational data model. That means we talk about some related data. I told you related tables, right? So this is called relational data model. And our sessions, we discuss relational data model. So likewise, there are like network and hierarchical, which are known as very early, data models people have used. But the new ones, we have object-oriented, object relational, and even, there's no particular data model we use. We keep the data as it is, I told you. Then we can also classify database based on the number of users. For example, if only a single user is using the database, we can say a single user database. For example, in our course, we directly access our database. We store the database in our computer. So you can think it as it's a single user database system. But when it comes to practical applications, mostly we build system for multiple users. So some databases can be used only by one single user. And those are known as single user database management systems. If your database supports multi-users, that means multiple users can access the data. So most of the databases nowadays available, we assume that multiple users are using the database. Right. Now, if you look at what is happening nowadays, data will not be stored in one single place. Data is actually distributed. I told you about the Google search queries, and I told you the data come from multiple different databases. And these databases are actually located in different geographical locations, right? So these are called distributed databases. So depending on where you have the database, we can classify our database as centralized, which means we have a single computer with a one database. And the other one is called distributed databases. That means you have multiple computers and you have multiple, databases. So nowadays, mostly our databases are in a distributed manner. So data will not be in a one single place. There are a couple of reasons as well. The one reason is data availability, because we know that the computer fails. So if you store your database in a one single computer and the computer fails, you don't have access to the data. Therefore, the model that we use nowadays is the data will be available in multiple places with duplicates. So that's how nowadays we will access the data. Then another classification is based on the cost. Some databases are free, some are free and open source, some are commercial. Right? Oracle, for example, in our case, mostly catered towards as a commercial applications. But then there are some, databases like MySQL or MariaDB, for example, they are treated as fully, free and open source. So that depends on the cost involved in the databases, which means some are free, some you have to make some payments. So in an organization, when you want to make the decisions, so depend on your requirement, you can see that there are multiple different ways that you can actually select a database. So selecting what database we are going to use is a crucial. Although we focus on Oracle databases here because it's commonly used and it's the number one. So that's the reason why we are learning. But once you learn the basic, it will be more or less the same. So which means the knowledge that you have, the skills that you have get will be, could be available, or you can could be applied for the other databases as well, right? But there are differences. So therefore, I mean, which database to use is a one thing you have to, it's a crucial decision you have to make, right? When you're thinking about the practical applications. Okay, any questions? Okay, so I think I spent some time. Right. Now that we have discussed the basic idea, I think as the beginners, as well as like since you are working in the industry, maybe you need to understand how typically we design a database. So in this one, I will discuss formally how you might design a database and what are the different stages involved. But it's not necessary to follow the same pattern. There are some exceptions, especially, for example, agile world. Usually we don't focus on much on the traditional way of developing databases. But it's always remember that having some steps to do something will be helpful for you. So let's look at how you may design databases. Right. Okay. So in database designing process, the problem is we are going to design a logical and physical structure of one or more databases to accommodate the information needs of the users of organization for a predefined set of applications. So for example, if I say a university system, we need to define our logical and physical structure for a database. And it might be a multiple databases because, for example, academic information we could have in one database, and financial information could be in another database and so on. So depending on the requirements, we have to make the decision. And the goals of the designing process is we need to satisfy the content requirements when we talk about the data, and also provide some structuring information, because relational databases, we always prefer to have some structured information. And then we have to support the processing and performance objectives. When you say processing requirement, means your data requirements. Sometimes we need to need data, or for example, summarize or aggregate data in different levels in quarters, years, and so on. And then sometimes we have performance objectives. We might be able to, get the results within a couple of seconds. So these are sometimes we call performance objectives. So like in financial information, like some of you are working on, if it is in financial market, for example, the performance objective is more important than any other requirements. Right? So that we need to have clear in the very beginning. And these are the goals of typical database design process. So let's try to understand the different phases available. Like in any software applications, any other project where you have, the first task would be you need to collect the requirements. Since I talk about the university, so in the typical university environment, we have to collect the requirements. So that will be the requirement collection and analysis, which means we have to gather information from different users, from students, the lecturers, the administrators, the vice chancellors, what their requirements are. Because based on their requirements, we are going to make the database application. Once we gather all the information requirement, we need to design a conceptual database design, which means a high level design where we will identify different, what we call entities. For example, student is one entity, courses will be another entity, right? The section could be another entity and so on. So we have to provide a very high level database design. Then once you have this design, we have to make a choice of what database management system to be used. For example, if you go back, right, there are many different types of databases available, right? For example, let me go back to my original slide on different databases, right? I told you the popular is Oracle, but Oracle will not suit for all our database systems tasks. So different, requirements are there, and depending on different requirements, we have to select the database. And remember, we talk about the database model, and I told you what we are going to focus on the relational databases. And you can see Oracle, MySQL, SQL Server, PostgreSQL, they are all relational. But then if you look at like MongoDB, we define everything as documents. We call NoSQL database. Likewise, there are other types of databases also available. So once you gather the requirements and once you develop the conceptual model, then you have to choose among the set of databases which database to be used for your application. So it's very important that you make that choice. But sometimes this choice comes with, organization as well. For example, if the organization is expertise in Oracle, maybe then your choice would be Oracle database. Or if you experience in Oracle, maybe then your choice would be Oracle. So likewise, the third one is you have to decide on the database management system. Once you choose the database management system, you have to make the data model mapping. We call logical database design. In our case, it will be creation of database, creation of tables, and creation of the relations, right? Like primary keys and foreign keys, which I will discuss later on. So that is what we call the database model mapping. Then physical database design, which means we focus on the actual storage of data, optimization, how you might access the query. You have to optimize the time it takes to execute the query. So that comes under physical database design. And next one is implementation. So you implement the database, which means you create the database, you store the data, and then you perform some queries and see whether you meet all the requirements. And then based on that, you make tuning. When we say tuning, sometimes it might be your SQL statement. So like some of if you are familiar with SQL statements. So depending on the way you write the SQL statement, it will take different times. So maybe you have to rewrite so that you will get an improved, the time. So that is a performance improvement. You have to rewrite your SQL statements, right? So that comes under database system implementation and tuning. If I show you graphically, right, this can be, in this one, we can show you, two paths. The first path, what you see is database development. Second path is actually application development. Right now, what we are going to discuss is this part. In this module, we are focusing on how do you get the data requirements, how do you define the conceptual design, how do you create the logical design, how do you design the internal schema, and then we can also talk about the different SQL statements. This part only focus on the database management system. But usually, along with the database design, we need to define application as well. For example, let's assume that we are developing a web-based system. So that means depend on the web-based system, we have to develop that aspect as well. So this is what we referred here, right? So, and these are all the phases that we have discussed. So during the requirement collection and analysis, in data part, we gather the data requirement. Whereas application, those who are developing application, they gather the processing requirements. For example, now under the data requirement, we can say things like, okay, we want to store name of the student, and the number of characters we require to store is, let's say the maximum number of characters for the first name, let's say 80 characters. That is a data requirement. Now processing requirement is something like, okay, how many users can access the data for a given time? You can say things like, okay, 10 users, 50 users, 500 users. So there are some limits, right? For example, now Zoom, we now interactively access or interactively have the session through Zoom. So you have some limits, the number of users who can log into different on depending on the Zoom session I have created. So likewise, so the database application, you have to have processing requirements. So conceptual schema we design. So this part I will discuss in coming session. Then logical schema, we create database, tables, foreign keys, primary keys. Then internal schema, we discuss about the indexes, different views we can discuss, and then tuning about this. We can use different SQL statements to make the implementation and tune. Right. Okay, so let's now discuss a little bit more detail what we need in these different phases. When we say requirement collection and analysis, when you start your database application, you have to first identify different types of users. So for example, in a university environment, the database could be accessed by lecturers, students, and then maybe administrators, and then maybe the senior staff like registrar, vice chancellor, and so on. And then you have to interact with different users to get the requirement. So different users, different information. For example, a student, if you take it, what students wants maybe what courses particular students taking in different semesters, maybe their grades. But if you take vice chancellor, for example, maybe vice chancellor wants to know like how successfully lecturers delivered their sessions, maybe aggregated performance of students. You need different levels of requirements. Remember that when you're designing a database, this phase is very, very important. Why I am saying this, if you make a mistake in here, it will take quite a lot of time to correct it. So make sure that when you are designing a database, you spend time to gather exact requirement, right? So that's why it says it's very expensive to fix the requirement error, because it affects all the coming phases. If you make a mistake in the requirements, that affects everything, right? So it's very important that you carefully design. So in conceptual design, I told you it's a high level design. And when you design this conceptual design, we don't think about any database management systems in particular. So usually we say this schema or the structure, in short, we can say it's independent of actual database that to be used to implement this. So there are two parallel activities: conceptual schema design. At the same time, in the application development, you talk about transaction and application design. Choice of the DBMS, I told you it's very important. So choosing which database management system to be used is based on what type of data model that we are going to use. For example, right now, I told you our data model of a focus is relation data model, and we are using Oracle for that. Similar to that, you have to think about the storage structures and also the architectural options. For example, if it is a web-based application, you can choose any of the databases that we have seen. But if it's a mobile application, then you have to be very careful. Because if, for example, if you want to store the data in the mobile, you have a limited amount of storage available. And you have a limited processing power as well, which means you have to think about what architectures you are going to use. Second one is economic factors. Now, sometimes technically you want to do something, but the problem is you have to think about the cost. Each of the operations involved in different costs. For example, acquisition, maintenance, training, operating costs. It's not just you develop the database, right? You have to think about if you are implementing a database management system, you need to operating costs, you need the database administrators, you need application developers, and you have to train your users. Everything that there's a cost component comes in. And the second one is database creation. The last one is a conversion, which means sometimes going from manual to computerized. So if you have a manual database where you have a set of books where you have written information, you have to, somebody has to type, convert. Or if it is in a different types of a database system, for example, earlier commercial applications were written in programming language COBOL, where the data will be a part of the code. So if you want to convert this into a latest database, you need to use some different tools to convert the data. So there will be a conversion cost involved. Third one is very important. Now, irrespective of all these technical and economic factors, sometimes the organization, there's a philosophy, which means they prefer or they are very familiar with already existing databases. For example, if your organization is already using Oracle, and when you're developing a new application, they might prefer Oracle because they have prior experience with the Oracle database, right? So the vendor preference is that because you are very familiar with Oracle, and then you go for Oracle. And familiarity of the staff with the system, how familiar you are with the system. And the third one is very, very important. If it is a very complex database application, you have to have vendor services. When you get stuck in the design, you have to ask for help. One example is like there's a lot of criticism of using a free and open source software, because when you are using free and open source software for a commercial application, I mean, if you have some problem, there are less user support. There are community support is available, but if you are an organization, if you need a professional service, we have a very limited professional service coming from open source software. I'm not saying there's none. There are some database management systems provide you the services. Although the database is free for some fee, they will provide the support services, but you have to make sure that you have that support whenever you need it. Right. Logical database design, we discuss high-level data modeling to the required data model. So in our case, if it is a relational database management system, this step we create tables and make relations. We define primary keys and foreign keys and so on. And then the second one would be like designing external schemas for a specific application. I told you like different users need different data requirements. So depending on your data requirement, you have to design those. So there are two stages. One is system independent mapping. which means the DBMS independent mapping, or you can tailor the schemas to specific DBMS. So that means you select a particular database applications, but you define the schemas in conceptually earlier, which you transform or to meet into database. So for example, different databases, we have different data types, as well as in application programming also we have different data types. So that we have to make a mapping. So what is the outcome, which will be a set of SQL statements. For example, in our case, we will use SQL here to define our database. Then physical database design. I told you physical database design comes at the implementation level. That means data storage level. So we can talk about storage structures. How do you place your records, and also placing indexes. And for this is very important. I told you about the design criteria comes in, how long it will take time to execute a particular query, which we call response time. And then also storage utilization, again, very important, because when you have a very large databases nowadays, if you're going to keep record on all the user interaction in a database, which will be huge, and space utilization is one of the design criteria. And then transaction throughput, how many transactions you can perform per minute, right? And then this could be measured in the peak conditions. We know that when people interact with the database, there are peak time. For example, in a typical organization, 8 to 5 will be the typical peak times, but they are also like maybe 10 to 12 might be the rush hour. Right? Usually people more active in those hours, which will, when you want to make the measurement, you should make the measurement in the peak time conditions. So what happens is outcome of this will be a storage structure and some access path. For example, when we say storage structure, so some databases will support 4 transactions. What do you mean by transaction? Is when you execute a set of instructions, if something fails in the middle, you have to either go back to the beginning, right? You make sure that your data is consistent, right? So we can, depend on our requirement, we can decide on what storage structure we want to use. Right. The last part is database system implementation and tuning. There are 2 parts, as I told you earlier. You have a database and you have application program. So in the database, we have to talk about the implementation, the data recording. You have to test whether the data is successfully recorded, and you have to make sure, you have to test. Similar to that, you have to test the application program as well. For example, if you're using a web application, you have to check what is actually available in the database as well as what is visible in the web interface, right? Whether they are matched to each other. And if it is a success, then you can deploy. Second part is very, very important, which I'm going to discuss very late after we discuss basic SQL statements, right? Now, for example, let's say we have a table with 100,000 records, right? And whenever we want to display the data, right? How are you going to select the data? Or let me say like this. Let's say I have 100,000 records about students. In a typical web page, we cannot show everything, right? We have to limit our data. So that means whenever you want to display your data, you have to make limits. So that is one of the tuning you can perform. For example, let's say your web page, you can display only details about 10 students, then you should pick only the first 10 records. Next, you have a next 10 records, next 10 records, and so on. So that means you have to tune a database so that you are not going to access everything. What will happen if you make a mistake and if you're going to access all the 100,000 records and trying to display in a web page, then it'll be unresponsive. Your website might crash, or it might take quite a long time, right? Remember, very important. So during the database tuning, we look at the performance of the database. We look at the indexes that we have used, which means what attributes we are going to focus on when you are retrieving the data. And also we can talk about reorganizations. Sometimes the data could be in two tables, but let's say if you're going to join the two tables frequently, we can create a view instead of joining the tables frequently. So these are the kind of the reorganizations we can do to improve the database access. And this is a continuous process because it's evolving. User requirements are changing. So the maintenance usually will over and over again, you might tune your database to suit your requirement. Right. Okay. So let's look at conceptual schemas. Now, when you talk about the high-level view of the data, the model that we will create, we call conceptual schema. And one of the modeling technique we are going to use is called ER model. This ER stands for entities and relationships. That means when we have a data requirements in high level, we look at different entities, and then we are going to talk about the relations. Now, let me give you an example. In a university environment, we have student. So student is an entity. Then we have courses. So course is an entity, right? So what is the relationship there? The student takes courses. So takes, for example, is we call a relationship. So entity and relationship means any data requirements we view as entities and relationships. So student take courses. So student and course are their entities. The relationship between course and the student is takes. So that is a relationship. So this is one of the commonly used modeling technique, and that's what we are going to learn. Right. So if you follow this modeling technique, we get what we call ER diagrams, which we have entities and relations. So the couple of things that we are going to discuss under this is we talk about entities, relationships, and attributes. So entities, I gave you an example, student. Another entity is course. And then takes is a relationship. Then attributes are used to describe entities. For example, if you take name, date of birth, they are attributes of student entity, right? So these are the things, the components that we use to describe ER model. Okay, now let me give you a simple example where we talk about a description and a ER model, right? So what I'm going to do is I will present you some description, and based on the description, we are going to build a ER model. So you can think this as a requirement collection. So whenever you want to design a database, you can collect your database requirements, and then based on that, you can build the model. And later, what we are going to do, we will use SQL to convert this model into create a SQL statement where we can use it to actually create the database. Right. Let me start with a small example. So this is known as company database. This is a description about a company, right? I have highlighted some of the words to understand different ideas, right? The first one, you can see the company is organized into departments. So which this will highlighted one is an entity, which is what we are going to represent in the ER model. Okay, the next statement says each department has a unique name, unique number, and an employee who manages the department. Okay, so these ones are described the attributes. So the department we can describe using a name and a number, right? And it says we keep track of start date of a department manager. A department may have several locations. Okay, so the location is another attribute which will describe the department, right? And there's another one. We have an employee who manages the department, which means we talk about the relation here. I will come to that point after we discuss about the employee. So let's move to the second state. Each department controls number of projects. So you can see this is an entity. Each project has a unique name, unique number, and is located in a single location. So these projects can be described using a name, a number, and a location. Next one. We store each employee's name, social security number, address, salary, sex, and birthday. Okay, now we describe another entity. And you have set of attributes, social security number, which is like a national ID card number in US. Then address, salary, sex, and the birth date, which describe the employee. Each employee works for one department, but may work on several projects. Okay, this statement actually describes some relations. The relation between employee and the department and project, right? I'll come to that later. We keep track of the number of hours per week that an employee currently work on each project. So that is about another attribute on a particular relation. We also keep track of direct supervisor of each employee. So that means here we can again talk about a relation, which is there are some supervisees and supervisors. Last line, each employee may have a number of dependents. For each dependent, we keep their name, sex, date of birth, and relationship. Again, another entity. And these entities described using name, sex, and date of birth. Right. Now, let me show you the ER diagram. So this is the graphical representation of the description. So during the conceptual model development, we collect our information, and this is a description of the data required. And as the first step, what we do, we develop ER diagram. This is the ER diagram based on this description, right? So I will explain each and every step again, but you can see now our requirement is once you gather the information, and that information you have to put it into a diagram like this. And once you get the diagram, in the next step, we can convert each of these into relations, or in other words, the tables in a database. So that's what we are going to do. Right. Now, having said that about the diagrams, now let me briefly explain how we can represent things, right, in ER diagram. And then I will go back to the statement and I will describe how the diagram reflects the description that we have seen in the beginning. Right. The first thing is about the entities. Now, entities means the objects or the things in the real world, which we are going to focus on the database application. So, for example, we can talk about particular employee, John Smith, it is an entity. Or we can talk about a particular department, research department. Or we can talk about a particular project, productive. So these are called entities. Then attributes, I already told you, which describe the entity. So employee, you can have name, social security number, address, sex, and the birthday. Right? And each entity, you have a specific value. So I told you, like when you take an entity, you have a set of attributes. So for example, if you take a employee entity, and then if you take a name attribute, you have to have some value for name, like John Smith. So those are known as values. Next, each attribute is coming from a set of values. For example, if you take a name, the name is a string, right? And if you take, for example, gender, male or female, we normally call enumerated type. That means predefined set of values. Right. Now, when we talk about attributes, there are different types of attributes available. First one, we can have simple attributes, like you have a single atomic value. Like, for example, you have social security number, like our national identity card number, or sex meaning gender. So you have a single, atomic value. We call simple attributes. Then you can have composite attributes. Composite attributes means you have several components. Like, for example, if you take name, we can define a name as two parts, like first name and last name. So we call composite attributes. Next, you can have multi-valued attribute. Now, for example, if you take a car nowadays, you can have multiple colors, dual colors, for example. Let's say black and red. That means you have multiple colors. We call multi-valued attributes. Next, there could be derived attributes. For example, usually we can keep date of birth. But if you take age, for example, you can define age using a date of birth by subtracting, today's date with the date of birth. You can get or calculate the age. So this type of attributes are known as derived attributes. Then you can have both composite and multi-value attributes. You can have combination of all these. Right. Now let me show you all these attributes in the diagram. Right. Now, when we look at a description like this, you need to first understand what are the attributes, what are the entity types we call it. Right. For example, department is an entity type, and we have attributes name, number, right? And then location. So these are the three attributes for the department. So if you go here, you can see here department, we have name, we have number, we have locations. Now you can see here the name and number, they are simple one. It says unique name, a unique number. And then say have several locations. It says multi-value attribute, right? So when you have multi-valued attribute, usually we use double logos. So this will represent a simple attribute. It's a name, simple attribute, a number, and then we have multi-valued attribute locations. You have double logos. And entity types usually represent the rectangle shape. So the department, you have name, number, and location. Now, when you have unique values, we use them as key attributes. We normally underline key attributes. Since both name and number both are unique, you can see they are underlined. Right. So let's look at another entity type. Now, if you look at the department controls number of projects. Project has unique name, unique number, and located in a single location. So let's look at the project now. So we have project here. Name, it's unique, underline. Number, it's unique, underline. Location, it's a simple one, just one, oval shape. That's a project. Let's look at another one. We store each employee name, social security number, address, salary, sex, and the date of birth. Right? If you look at that information, employee, we have name, social security number, sex, address, salary, birth date. You can observe here a couple of things. Social security number is usually unique, like a national ID card number. And the name, this is shown as a composite attribute. Composite means when you have multiple parts, you can represent like this. Usually we know when you want to represent names, we can represent as first name, last name, or we can have initials and surname. So they are represent like this when you have multiple components, right? So that's why you will see several ovals. You have a name attribute which connects to employee type, entity type. But then name, you have three components like first name, middle initial, and last name. Okay. So I hope now you got an understanding about the entity types and the attributes. So let's look at the last one as well. Now, when we have dependents, for each dependent, we keep track of their name, sex, date of birth, right? And relationship, which is actually relation. But I think these are the three attributes. Now, if you go to the here, we have dependent, name, sex, date of birth, and the relationship. Okay, in this particular case, we are going to keep track of that. So this is also a attribute. So you can see here. Now, in this one, unless look at the others, we don't have any unique attribute, because name could be, you can have multiple, name, same name. So therefore, you can see dotted line here, which represents a partial key. Since you have partial key, we use double rectangle here, which means that this is called weak entity. Now, we talk about weak entity when you can't find a unique attribute within the entity, right? Okay. Now, I hope we understood the idea of entities, attributes, and then the type of attributes in general, right? Okay. Let's discuss more ideas. When you have attribute, when you have a unique value, we call it a key attributes. This is called uniqueness constraint, which is again important. So when you define something as a unique value, right, you can't have duplicate value. It will be a constraint. So the social security number of an employee is a unique value. National identity card, unique. Passport number, unique. Driving license number, unique for a particular person, right? So these are known as usually key attributes. Sometimes when you cannot find unique attributes with using a single attribute, you can actually combine multiple values together. For example, if you say vehicle tag number, it suggested that you can have two components. You can have number and a state. Like in early days, we had the registration number and the province, something like that, right? So this indicates that sometimes you can have composite attributes. That means sometimes we might not be able to identify each of the record using only one attribute. Right. Sometimes you can have more than one key. So this already have identified earlier. For example, in employee, we can have social security number, you can have national ID card number, you can have passport number. So which means you can have, more than one key. It's possible. Right. So here are the symbols we have used. So the rectangle shape we use for the entity, we call regular entity. Remember, all these regular entities, we have to have unique attributes. So that means you have to have key attributes. If you cannot find any unique attribute, then you will have partial keys. Then we call it a weak entity. Then we will use diamond shape block like this for the relationships. And you have double lines, double diamond shape block like this, which is for all identifying relationship. Let me discuss these now. Now, the relationships you can see between entity types. For example, in our description, we say employee works for department. So works for is a relation. So this is called relationship. So employees works for department. And then we say some employees manages the department. So manages is another relation. Then we say department controls project. This is another relationship. Employee works on projects, another relation. Supervisors supervisees, right? So this is called a recursive relationship. Now this is a partial one. This is called weak entity type. Therefore, this is called identifying relationship. So dependence of, this is called identifying relationship because it's weak. Right. Okay. So now I hope you understood the idea of entity types. So we discuss about the entity types, weak entity types, the relationships, identifying relationships, attributes. We have already discussed the oval shape. If the attributes is unique, you have an attribute which we underlined. Then if you have multi-valued attributes, you have double ovals. If you have composite attribute, it will be look like this. For example, name, we can have multiple components. If you have address, you can have, for example, number, the street, and the city, for example. Composite attributes, we represent like this. If it is a derived attribute, like age, for example, we can have, dash lines. Or things like, okay, number of employees. So it's with dash lines. Okay, so that is the basic, explanation of ER diagram. So giving you a small description like this, now you should be able to come up with ER diagram like this. Right. Now we left with only one thing. That is what kind of relations we have. So when we talk about the relation, there are different types. First one, we can have the number of records which involve in the relations. So for example, if you take one record, and if that record is connected with only one record, we call one. So there could be one-to-one relationship. That means exactly one record will connect to the exactly one record from the other side. Then we can have one and n, one to many records. One record will connect with many records from the other side. Then many to many records. Many records will connect with the many record from the other entity. So this is the other one. This is called candidate. Then we can have single line and the double lines. Single line means partial participation, which means not all the records will participate in this relation. This double line means total participation, which says that, okay, all the instances are participating in the relation. Okay, let me describe this in the diagram. Now I'm going to go back to the ER diagram. Right. Now let's look at it. Now employees works for department. This is a relation. Now what kind of relations we have? Take one employee from this side. One employee will work for only one department. That's why we have one. Take one department. How many employees are working? Many employees. So this relation is known as one-to-many relations. Okay, you take one employee, works for one employee works for one department. You take a department, there could be multiple employees. So we put one N in, which indicates that this is one-to-many relation. Okay, let's look at here as well. Department controls projects. A particular department, if you take one department, can control many projects. So this side we have it. Take a project controlled only by a one department. So this is known as one-to-many relation. Okay, let's look at this. In this particular case, you say one employee can work for many projects. A project can have many employees. So we have many-to-many relation. Okay, last one, this relation. If you take one employee can manage one department, like it's the head of the department, right? And department can also have a one employee as the manager. So it will be a one-to-one relation. So look at the numbers, number of records which connects the other relations. So based on that, now we can say it's whether it's a one-to-one, one-to-many, or many-to-many relation. Right, now let me explain the total participation. Now let's take all the employees. All the employees work for departments, so which means you have a double line here. All the department you have employees, so you have double line. So double line means all the instances will connect with the relation. What about the managers? Not all the employees works as managers, right? Not all, some of them, right? So therefore this is partial. But if you look at the department side, the department should have a manager. So therefore this is double line. Similar to that, look at here. If you take a department, not all the department are having projects. So that's why this is a single line. But if you take a project has to have a department. There's a controlling department. So you have a double line. So that's the understanding between total and partial participation. So if you go through the description and if you go one at a time, identifying entity types first and their simple attributes, and then you identify relations. Then once you identify whether they are one-to-one, one-to-many, and many-to-many, and finally total and partial participation, which will complete the ER diagram. So I think we have discussed all the necessary information due to come up with the ER diagram, which is a conceptual model. Remember, I told you we are going to develop 3 different models. And this is the first one. So once you get the required information, this is the requirement analysis gathered from your data requirement. And once you make the conceptual design like this, right? This is called the conceptual model. And remember, this is nothing to do with any of the database. So that's why we said this model is independent of the database. You can use any database system to implement these relations, right? You can use any database system. So this is normally we call independent of the database management system. Okay, with that said, I would like to conclude my session. So our first session, we discussed the basics, introduction to the relational database management systems. We discussed what a database management system is, their components, three-schema architecture, and then we finish our discussion with developing ER diagram. We discuss the steps, right? So next session on Thursday will be practice. We will have some group work among yourself, giving you different descriptions, come up with the ER diagram. Therefore, I would like you to revisit what we did, mapping from the description to the ER diagram, right? So I will post the video so that you can go through the material we have covered. And once you are comfortable with this, then we will have a group work in the next session. That will be the first part. So once you get that, I will discuss the mapping part, which will be the second session for mapping part, right? Okay, any questions before we finish today? Okay, am I, okay, maybe I will switch off the recording.